Alrighty, so what are we going to be doing today? We're going to be finding the area between two curves. How are we going to do this? We're going to take the integral and we're going to break it up in different pieces and in slightly different ways to be able to work them out. So basically what's going to be happening here today is we're going to be looking at sort of different cutouts and how do we uh, make us able to actually figure out what these measurements are. So let's start with this first one. I started with kind of a wacky one, so I'm kind of excited about this because it's really cool. So before I show you what to do, I want to show you the dilemma. Okay, so the dilemma is this. I know how I'm gonna integrate this, right? I'll take this curve and I'll go from -5 all the way to 5 because that's what it tells us, right? Of x times the square root of 25 minus x squared dx. And I can't do this directly. I have to use u substitution. So I'll do what's on the inside. So my u is going to be 25 minus x squared. My du is going to be, well, that cancels out when I take the derivative, and we're left with -2x dx. And I know that I need to take this -2 divided over so that I get the x dx part like I should, so I can cash that in for du. So really what this is -1/2 du equals x dx, right? And so I plug all that in, and what I get is, and that -1/2, I'll put it outside because I don't need it on the inside. And I get, remember, square root's a 1/2 exponent. And that's what I get. And this is easy to do. I can totally do this. The rub comes in when I try and deal with the limits of the integral here, because when I plug in -5 on the bottom, I get 0. Okay. So far, so good. But when I plug in 5, I also get 0. And so you look at that and go, oh God, what do I do? Because I need to find the total area of this whole thing. And it's like, oh no. If I try and do this, it's just going to be 0 anyway. And that's obviously not true. There's area here. There's area here. And so whenever you're actually trying to find the total area, what you want to make sure that you do is split this up. You'll find this one, and then you'll find this one separately. So all the stuff that we've done so far, it's all good. It's everything that we want to have happen. It's just we're not going to go from -5 all the way to 5. We'll do the -5 to 0 part, and then we'll do the 0 to 5 part, and then we'll see what we get. All right, so let me maybe move some of this over. You go over here because you're good. But what we don't want to do is we don't want to do this. Not with these limits. So we're gonna break this up. We're gonna do this part first, from -5 to 0. And then we'll do from 0 to 5 as well. So here, look at what we have. We've got from 0 to 5. So we're still doing this -1/2, this part, but now we're going from -5 to 0. So I plug in -5 right here, I get 0 down here. I plug in 0 here, I get 25. So far, so good. So we're going to do this part. We integrate. This negative 1/2 out here stays. And then we integrate u to the 1/2 and we get 2/3 u to the 3/2 from 0 to 25. The 0 part, that's great. We don't have to think about that. That's just going to come out to be 0. This 1/2 and this 2/3, they combine to make negative 1/3, right? So u is 25. So we got negative 1/3 of 25 to the 3/2. So square root first, then cube it. Square root of 25 is 5. Cube it is 125. So this gives us negative 1/3 times 125. Or if you prefer, negative 125 over 3, right? Negative 125 over 3. Now I want to point out, if I'm trying to find the total area of this whole thing, if I have this be negative, and then this ends up being positive, they're going to cancel out, and I don't want that. When we're talking about in real life, like in the, like when we are measuring area as in terms of like actual physical things, you can't have a negative area. So even though this says negative 125 over 3, we don't have to worry about it being negative. The negative is just our problem telling us, hey, that's below the x-axis. So the actual measurement of this piece is that. Or 120, sorry, 5. That's a 5. Yeah. The actual measurement of this piece right here is this. So now we're going to do the exact same thing, but with this next piece. So same thing, and actually a lot of this is the same. If I plug everything into my, right, because this isn't changing. And if I plug everything in, 0 gives me 25. Plug in 5 here, it gives me 0, right? And me personally, I don't like seeing my limits of integration backwards from what they should be. I like the smaller number on bottom and the bigger number on top. Call me traditional. So I'm going to flip these, which means that I change the sign. So this is going to be positive 1/2 times the integral from 0 to 25, which is exactly what we had before, right? So we know that our final answer here is going to be just the positives. It's going to be 125 over 3. Just the same, for the exact same reasons that this was. I integrate u to the 3/2 times this mess, which simplifies to negative 1/3. Plug in 25, square root, cube it, get 125. And so this is also 125 over 3. So if I want the total area, I'm just going to add these. 125 and 125 makes 250 over 3. So if they're talking about the total area, what they're asking you to do, just when they say, they're asking you to, okay, well, consider the positive parts and the negative parts separately and just do them separately, just like I did. All right. Let me let me move on to the next one here. All right. With this one, notice that they want this area here in between. So what's really happening here, I'm gonna draw this and then I'll move it to make room. But what's really happening here is we're taking this block under y = 5, and we are subtracting the part underneath the 5 cosine squared part. And what that leaves us with is this part. So how do I do that in my integral? Well, you can either, and this is up to you, you can either choose to do 2 separate integrals and then subtract them if you want, Or, if you prefer, you can also instead do this as a single integral, right? Like this. So first of all, from 0 to pi, right? That's where these two meet. You've even got the picture here of this minus this. Because there's our bottom limit, there's our top limit of 5 minus 5 cosine squared of x dx. This whole thing dx. And then the integral of cosine squared, what we probably should be doing is we should probably be using a trig identity to make our lives easier. So how are we going to do that? Well, cosine squared, there's a formula for this, the double angle formula. If we know cosine squared of x, I'm going to put this down here. Cosine squared of x is the same thing as 1 plus cosine of 2x over 2. So now what we can do is we can put that in for cosine squared of x, and that'll give us something we can actually integrate. We don't know how to integrate cosine squared, not unless we were to memorize it, and ain't nobody got time for that. So let's do this. From 0 to pi of 5 minus, and I'm going to 5 times 1 plus cosine of 2x all over 2. And it might help us to simplify this a little bit, all right, because this is 5 minus 5 over 2, because you distribute, and then you distribute the division as well, minus 5 halves cosine of 2x. And see, now I can just integrate. I mean, yeah, I could even combine these. 5 minus 5 over 2 is 5 over 2, right? But, that's sort of up to you. So we integrate. And then we integrate cosine. That's sine. And since it's a 2x, we divide by 2, right? So this is minus 5 over 4 of sine of 2x from 0 to pi. So once again, with this situation here, let me move everything over just a little bit so we have enough room to continue. Go over here, and then maybe shrink you a little bit. There we go. So, again, you plug in 0, sine of 0, still 0. So we're good there. And you plug in 0 here. So all we have to do is worry about the pi part, right? So we've got 5 pi over 2 minus, what's sine at pi? Also 0. Even better, right? I love it when these things just sort of go away. It's great. So our answer here is 5 pi over 2. And that's all. So this minus this part, we're left with 5 pi over 2. All right, let's move forward. Okay, so here, first of all, let me make that bigger. I'm saying to myself, well, First of all, this is done really weird. All right. The X's and the Y's are backwards. And that's fine. We actually are going to have two different ways that we can do this. We can either do this in terms of X or do this in terms of Y. Since it's already in terms of Y, my recommendation would be to use the Y values. So we're integrating over Y from the bottom to the top, right? From 7y squared to 7y cubed. So top minus bottom. And what are we going from? Well, since it's in terms of y, let's look at the y values. From 0, 0, so the y value of 0, to the y value of 1. And instead of dx, since we're working with y, it'll just be dy. Very easy. So let's do this. Integrate 7 thirds, 4ths y to the 4th minus, my pen gets ahead of my brain sometimes. And then this one is going to be to the 3rd power, so 7 thirds y cubed. We're evaluating this from 0 to 1. Well, again, if we plug in 0, these are just going to go away. So it's the 1 part that we have to look at. 7 fourths minus 7 thirds. And here's the thing to note is that if you get a negative number for these, it just means that you put your terms backwards. I did top minus bottom. In reality, think about what the top is with regards to y, right? So this should have actually been 7y squared minus 7y cubed. My brain was trying to tell me something. But yeah, I mean, it doesn't matter. You're going to get the same answer anyway, just you get the negative, then it's backwards. And you could, however you want to do it. But when you're finding the total area of of a region like this, if you get a negative number, probably the only thing you did wrong is you flipped the terms. So I'm showing you here now what I did is I went backwards because I'm going to get a negative number here, right? Like this will be 21 over 12 minus 28 over 12. So this would be negative 7 over 12. But here's the thing. Areas are always positive. So all you got to do is, like if you had a problem on the AP exam where you did this, my area is 7 over 12 units squared. And then you get all your full points. As long as your final answer, you say this and all of your scratch work. If you get that and you say, oh no, you know what the easiest simple solution is? Say plus sign and then put a negative sign around everything and say, hey, no, I meant to do that the entire time. All is well. And then you're right. But don't overthink these. Even if you do the wrong one in front and the wrong one in back, as long as you recognize I got a negative number, it should be positive. I just flipped the terms. So let me make it positive, and then you're fine. All right. Now, notice I've no longer given you a picture here, right? So what that means is that you're going to have to find the bounds of integration yourself. And so let me show you what to do. So we want to find the y, because again, this is all in terms of y, so we're doing something dy, right? So all we have to do is set these equal to each other. And I'm looking to see which one of these has the biggest exponent. That's this one. I'm going to move everything over to the other side to make sure that my biggest exponent is positive. Standard form, you know. So I'm going to subtract the 12y squared. So 2 minus 12 is 10. And then minus 2y equals 0. And what's going to happen is I'm going to get 3 answers here. But I'm telling you right now, these directions right here tell you if you get a negative answer, you could ignore it, right? I wonder why I'm telling you that. So let's first factor out the greatest common factor. There's a 2y that I can pull out. So already we know that one of our bounds of integration is y equals 0 from this one, right? Let's factor this one out. We should get something like that. Yeah? Double check. 6y times y, that's 6y squared. 1 times negative 1, that's negative 1. 6 times negative 1 is negative 6, plus 1 is negative 5. So I'm good there. So let me solve. This one comes out to be a negative 1/6. Well, that's not good. That's not greater than or equal to 0. So I can ignore this one. This one is meaningless. This one comes out with y equals 1. Hey, there's my other bound of integration. So I'm going from 0 to 1. And once again, it doesn't really matter which one of these is on top or on bottom. If you get the negative answer, just flip it around, right? So we're going to subtract these. And, it doesn't matter which way we go. Negative 12. I'm going to put them in standard form. Going to subtract. So 12 minus 2. So 10y squared. Then subtract. So plus 2y. And you see it's kind of the opposite here because this time I subtracted from the other side. If you just want to use this, you can just throw that in there. It'll give you the same answer. It's just a matter of what you want to do. So I'm going to integrate this. And again, maybe I'm backwards, maybe I'm forwards. It doesn't matter. Just when you're done, make it positive. So I'm going to integrate. Ten y cubed over 3. And then this is 2y squared over 2. It's y squared. This is a negative 3y to the 4th. Just to simplify here a little bit. And again, one of the great things here is I'm plugging in 0. All these are going to 0 out. So the only thing I have to worry about is the 1, right? So I do this 1, 1, 1. So whatever that is, right? Looks like it's 1 and 1/3, right? If I was to rewrite all these in terms of thirds, so this is negative 9 thirds plus 10 thirds plus 3 thirds. 10 minus 9 is 1 plus 3 is 4 thirds. And I got the positive answer, which means I was doing it right the whole time. Yes. All right, let's continue. So we're going to have times when there's lots of different ways to do a problem. And I'm never going to tell you one way is better than another. Like, for example, if you were like, I don't want to change these variables and do this in terms of y, you could say, all right, well, where does the top change? The top part changes here, right, at 5. So you could, if you wanted to, make 2 separate integrals from 0 to 5 of top minus bottom, plus from 5 to 6 of top minus bottom. And you're going to get the same answer if you do it the other way. I'm going to show you both ways just because, you know, we can. Don't forget your dx's. So integrate. This is going to be x squared over 2, so 2/5 x squared minus, this is going to be a 3, so minus 1 over 27 x cubed from 0 to 5. And then this one, when we integrate this one, we're going to get 4x minus 1/27 x cubed evaluated from 5 to 6. And then you do this, and this one is great. The 0 cancels out, so we're just left with the 5, right? So 5 squared here, 25, so 50 over 5 minus 5 cubed, 125 over 27. Plus this one you have to deal with. Okay, so plugging in 6 and plugging in 5. So plugging in 6, this is 6 times 4 is 24 minus 6 cubed over 27, 216 over 26. We'll simplify that in a little bit because there's something you can pull out of that for sure. Minus evaluated at 5. So now we're going to have to do it evaluated at 5. 20 minus 125 over 27. Oh, and actually, if you notice, 125 over 27, 125 over 27, there's going to be some good cancellation. So this is actually going to come out real nice. I'm going to just sort of simplify what I can here. 50 over 5, that's 10, minus this part, plus, that's already simplified. This, 216 divided by 27. I think there's 3 factors of 3 in 216. Yeah, 6 times 6 times 6. 27 times 8. Yeah, that's right. So 216 minus 27 is 8. And then we're going to have to do minus, distribute this minus sign to both of these, minus 20 plus 125 over 27. And look at what happens here. This one is a minus, this one's a plus. So these actually cancel out. That's nice. 10, 24. So that's 34 minus 8 minus 20. That's 6. That's one way of doing it. And if that way works for you, awesome, great. Here's another way. All right, I'm gonna clear this out. So another way we could do this, if you're like, I don't want to have to do so many different integrals, well, you could turn everything in terms of, instead of having it be y equals, it could be x equals. So this one is going to be, x equals 5/4 y. This is going to, our bounds of integration is going to be from 0 to 4. That's good. And then this one, let's actually physically write this out and then square root both sides. X equals 9 square rooted is 3, and then the radical y is still in there. So these are our two. So now really what it is top minus bottom. So from 0 to 4, because we're doing it in terms of y now, we can do it all in one. 3 radical y minus 5/9 y. And so when we do this, we integrate, just double checking everything. That's a 4, not a 9. Okay, so we integrate. This 1/2 exponent is going to become 3/2. So we've got 3 times 2/3 y to the 3/2 minus this is going to be y squared. So this will be 5/8 y squared. So let's simplify, and this is from 0 to 4. The 0 goes away, which is nice. So these 3's cancel out. 2y to the 3/2 minus 5/8 y squared. So we do this again from 0 to 4. We only really have to worry about the 4 because when we plug in 0, they all go away again. 4, well, square root is 2, cubed is 8, so this is 16. 5/8 y squared, so 16. Divided by 8 is 2. So this is 5 times 2, right? 16 minus 10 equals 6. And that's the number we had last time, too. And so, really, two completely, perfectly fine different ways to do this problem. The question for you personally becomes, which madness do you want to have to deal with? Do you want to keep the variables the same, have it be in terms of x, so you don't have to change the variables, but then you have to do two integrals because they're sort of broken up, right? Or do you want to have one integral, make it easier that way, but then you have to change the variables? It really depends on which one you feel more comfortable doing, but you're going to get the same answer either way you do it. So don't be afraid to have a preference. Don't be afraid to say, you know what, I don't like doing it this way. I would much rather do it this way. You know, and it will help you. Okay. All right. So hopefully y'all are cool making sort of your own human, personal, adult decision about which way you like better. Because you can do the exact same thing here. Right? Once again, it's saying, well, here's this weird wave-shaped curve, right? One of those triangle waves. Do I want to break this up? Or do I want to integrate over y? And, you know, again, it's up to you. For doing it via x, well, it's from 0 to 2 of 4x squared plus 2 to 4 of 32 minus 8x. You do this 4/3 x cubed from 0 to 2. So this is 4/3. Whoa, what did I do? Sorry, weird things. Maybe my computer is haunted. So this part, and again, it does help to do these separately, you know. You don't have to try and do everything all at the same time. You can break this into pieces, you can chunk it out and not have to worry. But this is 8 times 4 is 32, so 32 over 3, and this is 0, so we don't have to worry about that one. And now we can get this other piece. 32x minus 4x squared from 2 to 4. And again, you'll do these separately. 32 times 4, 128, minus x squared, so 4 squared, 16, minus, so that's the evaluated at 4 minus the evaluated at 2, 64 minus 16. And then this comes out to be 64. This comes out to be 48. Yeah. And then 64 minus 48 is 16. So that's this part. That's this part. We can rewrite it 32 over 3 plus 16 written as over 3 is 48. So this is 80 over 3. I did it like this. Once again, if you would rather take the time to rewrite if you would rather take the time to rewrite in terms of y and then just integrate straight from 0 to 16, we can do that. So our answer was 80 over 3, right? So let's do this the other way. So once again, we're going to be solving for x here. So this one right here, subtract the 32, divide by -8. We end up with 4 minus 1/8 y equals x. The other one, divide by 4 square root. So we've got radical y 1/2 times radical y, right? So we've done that. That was quick. And then our integral goes from 0 to 16 because we're going on the y value, right? Of top minus bottom, 4 minus 1/8 y minus 1/2 radical y. So I'll put y to the 1/2 to make life easier for everybody. And then integrate, 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 integrate. 4y minus 1/16 y squared minus 1/2 times 2/3 is 1/3. 1/3 y to the 3 over 2. Evaluated from 0 to 16. Right? So now we can just do this exact same thing. 4 and again, the 0 is, it's awesome. It's great. We don't have to do anything with that 0 because we plug in 0 for everything and they go away. But it's that 16. So 4 times 16, that's 64. 16 squared divided by 16 is just 16. And then square root of 16 is 4. Cubed for 16, 64. Over 3. Well, let's do this part. This is 48. And then we'll write this in terms of over 3. 48 times 3. I want to say that's 144. I've been dumb before, so I'm going to do this out. 8 times 3 is 24. Yeah, see, I was right. Okay, 144 over 3 minus 64 over 3. And what's 144 minus 64? Darn well better be 80. Because they're supposed to work, and if one doesn't work, then you did something wrong, right? Just like a couple weeks ago with that one problem. It's just, got to make sure that you do your basic arithmetic correctly. Otherwise, Life is hard for you. So yeah, just be careful. But like I said, either way you do it, you're gonna get the same answer. And it's important that you know that either way you go, you're gonna get the same answer. As long as you do the right math, you're gonna have the correct answer. Once again, here, I've not given you the bounds of integration. I haven't. So you got to figure it out yourself. Well, where are these the same? Well, where is x squared minus 7 equal to 2? Well, let's solve for x. Add 7. Square root. Ta-da, there they are. Now, if you would prefer, you can also do this like with difference of squares binomials, right? You could write this as x minus 9 equals, and then x plus 3, x minus 3, and then you get x. Either way, your two bounds are 3 and negative 3. So just, whatever you would rather do. So, having convinced ourselves that this is the way, we're going to do x squared minus 7 and 2 as our curve boundaries. Now, it helps to picture this in your mind. X squared minus 7 is a upward facing parabola shifted down, and then 2 is just a horizontal line. So this should be with the 2 minus this part. But again, if you accidentally do it backwards, it's not going to kill you. You're just going to have to remember at the end to flip the sign. I'm going to distribute this so that it doesn't look so interesting. 2 minus x squared plus 7. And I'm going to combine my like terms because I want less to do. But it's your choice. You do you. But either way, we integrate. Negative 1/3 x cubed plus 9x evaluated from negative 3 to 3. Now, with these, it's really nice because you really only have to calculate it once because the negative sign doesn't do much except change the sign, right? So 3 cubed, that's that, plus 9 times 3 is 27, minus at negative 3. So yeah. So in going through, we're going to calculate this out. It's going to come out nice. This negative sign is going to flip these. So I'm going to collect everything. This is now going to be a plus 27, right? And then the negative 27 over third, negative 27 over 3 here. So this will be 54 minus 54 thirds. And this is going to be times 3 over 3, right? So 150 and 12, 162, right? So this is whatever 162 minus 54 is over 3. 162 minus 54, 8. Yeah, that sounds right. And there you go. Simple. Once we have the skills to do this, all this is doing the integration. And then I'll be honest with you, the hardest part is plugging stuff in. Everything else is just simple algebra or simple taking the integral, right? Once again, I don't give you a set of bounds of integration, so we have to figure that out for ourselves. Set them equal. The temptation is divided both sides by x, but then we lose one of our factors. We can start out by saying, hey, x is going to equal 0, and then we can have that there, but so I'm gonna be authentic here. Subtract the x over, factor out the greatest common factor. And so we definitely have x equals 0, and then x cubed minus 1 equals 0. When you're, oh gosh, how do I say this? When you're doing this, like, yeah, you could remember the formula for the difference of cubes. But this part is never going to result in anything. This is all extra garbage that is always going to have only imaginary solutions. There's an easier way to do this and still get the correct answer. Let's just solve for x. I'm not telling you how to live your life, but like, this is legit. So we're going from 0 to 1. And if we were to graph this, and this is where like just having pictures in your mind helps. If we were to graph, here's the graph of x to the 4th, and here's the graph of y equals x. So it helps to know which one's on top and which one's on bottom. So we're doing x minus x to the 4th. But again, I'm always going to be honest with you that it doesn't matter as long as you look at your final answer and go, oh, it's negative on accident, let me flip it around. Because otherwise it doesn't matter, right? Because we do this x squared over 2 minus x to the 5th over 5, evaluated from 0 to 1. Again, the 0, plug in 0, you get 0. Plug in 1, you get this, right? 1/2 minus 1/5, which, if we're going to do this, we might as well do it properly. 3 over 10, right? But on the AP exam, stop right here, right? You don't need to continue, just force the grader to do it for you, since they're paid for that, right? As long as you have plugged everything in, you can leave it unsimplified, and you should leave it unsimplified. Remember what I had told you, the grader is getting paid something like $1,600 for all this, plus free airfare, plus free hotel rooms, plus free food. You make them work for that. That's a nice vacation if you're just sort of letting them do whatever. So, make them work for their money. Alrighty, let's move on. We're going to find the area of the region enclosed by. So now we have 3 different curves. And once again, it really does help to draw the picture. Maybe drawing straight would be even more helpful, right? I've come to terms with my inability. That's okay. So here's x equals 2y squared. There we go. Looks like that. And then we have x equals 0 and y equals 3. So here's x equals 0. Here's y equals 3. So our region that we're actually caring about is this one in here, right? So once again, it's really up to you. Would you rather do this in terms of X or would you rather do it in terms of Y? I'm sitting here seeing this and saying it's going to be one integral either way. I might as well just do it in terms of the Y that I'm given. Now, if I know that Y is 3 right here, I need to know what X is down here so that I can do all my stuff, right? 9, this is 18, right? If I were to integrate in terms of X, I'd need to go from 0 to 18. But either way, top minus bottom, minus bottom is 0, so I don't need to do anything. And I'm going from 0 all the way up to 3. Then I'm just going to integrate. Two thirds times 3 cubed is 27. 2 times 27 divided by 3 is 18. Once again, I'm not going to do it the other way, but you could if you wanted to. If you wanted to solve for y and then integrate this over x instead, you do it. It works. You'll get the same answer regardless of which way you go.